Hello children, welcome back to my channel. I am now dealing with 9th class maths, quadrilaterals, exercise 8.4, fifth sum. 4 I have done in the previous video, now fifth sum. Fifth sum says that show that the line segments joining the midpoints of opposite sides of quadrilateral bisect each other. So let me first draw a quadrilateral. A, B, C, D is a quadrilateral. Then let me take E, F, G, H are the midpoints. What is the problem says? Show that the line segments joining the midpoints of opposite sides. Opposite sides, see, EG is one side and FG is one side. So the line segments joining the opposite sides of the quadrilateral bisect each other. So they are dividing at O. This is what you have to prove. What is given to us? We have got A, B, C, D is a quadrilateral and E is the midpoint of AB and F is the midpoint of BC. G is the midpoint of CD. H is the midpoint of AD. Then apart from it, you have got EG and FH are the line segments joining the opposite sides of A, B, C, D. Now, what is RTP? We need to prove that EG bisects FH. This you have to prove. EG bisects FH. And there is a construction. What is the construction? First bit you have to join EF, FG, GH, HE. Join EF, FG, GH, HE. And also you have to join AC and BD. This also you have to join AC and BD. You need to join AC and BD. Join AC and BD. Now proof. Let me take triangle ABC. In triangle ABC, E is the midpoint of AB and F is the midpoint of BC. This is given to us. They have given that E and F are the midpoints they have given. So when they have given like this, EF is the line segment, no? So the line segment joining the midpoints of any two sides of triangle is parallel to third side and also is half of third side. This is what the property. So therefore what we will say, EF is parallel to AC and EF is half of AC basing on the theorem which you have learned. So similarly, we can prove that Similarly, we can prove that GH is parallel to AC and GH is half of AC. Therefore, what you can say, EFGH is a parallelogram. Why? Because opposite sides are parallel and equal. Opposite sides are parallel. EF is parallel to GH, EF is equal to GH. So it is a parallelogram. So in that case, GE and FH, they are what, children? They are diagonals. EG and FH. Therefore, EG and FH are EG and FH are diagonals in a parallelogram. Diagonals bisect each other. Therefore, therefore EG bisects FH. Hence, proved. So this is the statement that we have proved, children. So please note it down. Once again, let me give you this explanation once again. This is FH. This is F, children. Properly write down FH. ABCD is a quadrilateral and EFGH are the midpoints of AB, BC, CD and AH. Now the question is the line segment joining the opposite sides. Midpoints of opposite sides of quadrilateral are bisecting each other. So for that, what we have done, we have joined EG of EFGH and also BD and AC. So even BD we are not using it. You can even think about only AD. Join AC and BD. So I even here let me write only AC is enough for the proof. BD is not required. So join AC. If you join AC, EF is parallel to GH. And see in triangle ABC, let me take triangle ABC. E is the midpoint of A, F is the midpoint of BC. EF is the line segment formed by joining the midpoints of two sides of a triangle. Then it is parallel to third side, it is half of third side. Similarly, GH also is parallel to AC, GH is half of AC. So, EH is equal to GH and EH is parallel to GH. So, EFGH is a parallelogram. If it is a parallelogram, FH and EG are the diagonals. The diagonals of a parallelogram bisect each other. Therefore, EG bisects FH. This is the proof, children. Please note it down. Now, sixth problem, children. It is ABC is a triangle, right angled at C, and a line segment, a line through midpoint M of hypotenuse. This is hypotenuse. This is the midpoint. Midpoint of a line through the midpoint M of hypotenuse AB and parallel to BC. Parallel to BC, this line is drawn and intersects AC at D. It is intersecting AC at D. You need to show that. What is that? D is the midpoint of AC. D is the midpoint of AC you have to show, and MD is perpendicular to AC you have to show, as well as CM is equal to ME. CM is equal to ME, and CM is equal to ME means you have to, this is CM. CM is equal to MA, that is half of AC we have to prove. So let us see what is given. In triangle ABC, angle C is 90 degrees. M is the midpoint of AB and MD is parallel to BC. Now, this is what they have given. What is RTP? What we need to prove? First bit is D is the midpoint of AC. And second bit, MD is perpendicular to AC. And the third bit, CM is equal to MA is equal to half of AB. Now, let us see the proof. How will you prove? First bit. See, M is the midpoint of AB in triangle ABC. M is the midpoint of AB. This is given to us. And MD is parallel to BC. This is also given to us. Therefore, what you can say, see, a line drawn through midpoint of one side of a triangle and parallel to the other side bisects the third side. This is the theorem, children, which we have learnt. A line drawn through midpoint of one side of a triangle parallel to the second side bisects the third side. Therefore, what we can say, D is the midpoint of AC. So this is first proof we have done. D is the midpoint of AC. Now second one. We have to prove that MD is perpendicular to AC. MD is perpendicular to AC means we know that DM is parallel to BC. This is given to us. Therefore, I can say AC is the transversal. AC is the transversal. If AC is the transversal, we can say that therefore angle D plus angle C is equal to 180 degrees. Why? They are interior angles. Interior angles on the same side of transversal. Interior angles on the same side of transversal. So 180. That means angle D plus angle C is 90 degrees is 180 degrees. So what is angle D? 180 degrees minus 90 degrees, that is 90 degrees. In that case, if angle D is 90 degrees, we can say that MD is therefore MD is perpendicular to AC. So this is the second proof I have proved. Now third proof. CM is equal to AM we have to prove. So for that let us take two triangles in third proof. In triangle ADM and triangle CDM. In these two cases, angle ADM is equal to angle CDM 90 degrees. Just now we have proved they are perpendicular, means they are 90 degrees, and MD or DM is equal to DM. This side is common for both, so they are equal, and AD is equal to DC. Why? Because we have proved D is the midpoint of AC. We have proved AD is equal to DC. Why? Because D is the midpoint of AC. This we have proved. Therefore, triangle ADM is congruent to triangle CDM basing on, see children, these two sides, this is common side angle side property. We can say two triangles are congruent. If two triangles are congruent, we can say that CM is equal to AM. AM is nothing but half of AB, because M is the midpoint of AB. Hence proved. So the total statements, or all the three statements, are proved here, children. So once again, let us see in triangle what is given to us. In triangle ABC, angle C is 90 degrees. M is the midpoint of AB and MD is drawn parallel to BC. We need to prove that D is the midpoint of AC and MD is perpendicular to AC, and CM is equal to AM, that is half of AB. This is what we need to prove. So for this, first proof, when you see, M is the midpoint of AB and MD is drawn parallel to BC. If a line is drawn parallel to midpoint of one side of a triangle and parallel through the second side, it bisects the third side. This is what the theorem which we have learned. So it is bisecting AC. So AD is equal to DC. This is first proof we have done. Now MD is parallel to BC. So angle D, AC becomes the transversal. Angle D and angle C are the interior angles on the same side of transversal. They are 180 degrees. So angle D plus angle C 180 degrees. Angle D plus angle C is 90 degrees. They have given, so 180. So angle D is 90 degrees. If angle D is 90 degrees, MD is perpendicular to AC. Second one also we have proved. Now third one, let us take these two triangles, triangle ADM and triangle CDM. In these two triangles, angle ADM is equal to angle CDM 90 degrees, because we have proved that MD is perpendicular to AC, and MD or DM, they are equal to each other. Why? Because common they are. And D is the midpoint we have proved, so AD is equal to DC. So these two triangles are congruent basing on side angle side property. When these two triangles are congruent, CM is equal to AM. And AM is what? Half of AB, because M is the midpoint. So this is how we have proved, children. Please note it down. Now with this chapter is completed, children. I will do new chapter in the next class.